All right, still in chapter 7 on percent. So 7.2 deals with solving basic percent problems. So we're going to have to use our skills from one where we convert from, percents to decimals or decimals to percents. So there's three main types and we'll go through each one of the types. But the key thing is on each of them, first we have to translate the words of the problem to an equation in each case, and then we solve it. Now, how do we translate? Well, our translation words, we have three of those. We have what. What does that mean? Well, that gets replaced with X. So it'd be like what number or what something. Then of, that's going to be times. We're going to multiply. That means times. And then is, that's equal to equals. Okay. Now, one thing here is when we get a number, and we can see down here we have a percent, we're going to have to convert the percent to a decimal to put into the equation, okay? So we can't just plug in a percent into the equation. We have to first convert it to a decimal, and then we can plug that into the equation. So let's look at the first one here. What number is 159.2% of 125? All right, well, what number? Well, our number, that's X. Is, well, that's equals. Again, we're just following these three words. Now we have 159.2%. Well, remember, when we have something like that, we drop the percent sign, we move the decimal two places to the left, and then we get our decimal value. So that's going to be 1.592 of times 125. Okay, so now we've converted this simple sentence into this simple equation, and now all we have to do is multiply to get the answer. So we take the 1.592 times 125, and so we multiply, so 5 times 2 is 10. Then we have 9 times 5 is 45, 46. And then 5 times 5 is 25, plus 4 is 29. And then 5 times 1 is 5, plus 2 is 7. Now we have 2 times 2 is 4. 2 times 9 is 18. 2 times 5 is 10, plus 1 is 11. 2 times 1 is 2, plus 1 is 3. And then down here we just get the first line repeated. 2, 9, 5, 1. And then we add all that together. So that gives us 0. 6 and 4 is 10. Now we have 9 and 1 is 10, and 8 and 2 is 10. That's 20. So now a 9 and 1 is 10, and 7 and 2 is 9, so that's 19. 5 and 4 is 9, and then we have 1, and we moved it 1, 2, 3 decimal places, and so then it looks like X is equal to 199, and that is the answer for what number is 159.2% of 125. Now, we're going to expect a number larger than 125, which is what we got. And so, just looking at it that quickly, we can say, okay, yeah, we have the right number. If we ended up with 19.92 and we wanted a number that's greater than 100% of that, then we know we've done something wrong. So you really have to kind of think about what does it mean and how does it work. Okay, so that's one type of the problem. And these are the next two. So this one says 9 is what percent of 50? Okay, so we say, well, 9 is what percent of 50? So 9 equals what percent X of times 50? Okay, so now we solve for X. All we have to do is divide by 50. Divide that by 50. So X is equal to 9 over 50. All right, but we can't just say, well, that's the answer because we need to put it into a percent. So first we have to find the decimal value of what that is equal to, and then we can convert that to percent by moving our decimal place two places to the right and adding our percent sign. So let's take 50 into 9.0000, however many places we're going to have to go. Well, it doesn't go in there, but it goes in here once, and that's 50. Okay, and so that's 40. Now we bring down our 1, 0 there. Now, how many times does 50 go into 400? Well, 8 times. That'll give us 5 times 8 is 40, so that'll give us 400. If we subtract, that gives us 0. So this is equal to 0.18. Now remember, we're taking that 0.18, converting it to a percent. So we move the decimal 2 places to the right. So that's going to be 18. We add our percent sign and we get 18%. So 9 is 18% of 50. So 18% of 50 is going to be a pretty small number, and 9, that makes sense. So that would be a good number there. All right. The next one is 132% of what number is 198? So it's written in a different way, but it really kind of looks like the other two. It's just in a different fashion. So we'll have 132, and it'll be better to write that as a decimal. And so remember, we drop the sign, move it to the left, and so that'd be 1.32 times what number? Well, that's x, we don't know, is, and that's 198, okay? So now we have 1.32 times x equals 198, so let's divide by 1.32, divide by 1.32, and so those go away. We have x on the left, and on the right, now we have to divide this, but remember, we can't divide by a decimal, so we have to move our decimal place 2 places here, so that means we'll have to move the decimal 2 places here, and so really we have 132 going into 198.00, well, 19,800. So what we need to do is go ahead and do that division. 132 into 19,800.000. Put our decimal there. Well, 132 will go into 198 once. So we subtract that off. 8 minus 2, that's 6. 9 minus 3 is 6. And now we bring down a 0. All right. So now how many times will this go into 660? Well, 6 is too many. So let's try 132 times 5. So that's 10. That's 15, 16. That's a 6. Oh, that looks good. So that's going to be a 5. That's 660. Subtract that, that's 0. Now we still have numbers here before this, so we have to bring down the 0. That goes in 0 times. And now we have the actual value. So now we don't care about the decimals after here because they're all going to be zeros. But we had to get the full number before the decimal. We had to get that whole thing before we could do that. So we had to go ahead and do that last division and get the 0. And so here, x is equal to 150. Okay, so does this make sense? 132% of 150 is 198. So we want a number that's going to be greater than 100% of 150 to get 198. Yeah, that makes sense. So it seems like we have the correct answer there. Okay. Now, what we're doing is we're just going to do a couple more examples of each. And so those are the 3 types we've seen. Now we just have to plug in numbers and be able to practice. And that's really what the rest of this is practicing those 3 examples, plugging in what is equal to x, is equal to equals, and then, of is times. And then just whatever falls wherever it is how we solve it. So what number is 10% of 70? Well, x is 10%. Now remember, when we do that, we drop the percent, move the decimal, so that's going to be 0.10 of times 70. Okay, that's pretty easy. And so now we're just going to take 70 times 0.1. We don't have to have the extra 0 there. It's just, 1 decimal is fine. And so now we multiply that. That's 0. That's 7. Move the decimal 1 place. 7.0. So x equals 7. And so that is our answer. Now, is 7 make sense for being 10% of 70? Well, 10% of 70 is 7. So yeah, that makes sense on that one there. So that was one of those simple ones. Math's not hard. The equation setup is not hard, and we get an easy answer. Now the next one doesn't look quite so nice because we have some decimals and numbers that are pretty close. So what we have to do is translate it and go ahead and do our division most likely. So 55.8 is what percent of 60? Well, 55.8 is what percent of 60? Okay, so now we divide by 60, and so those cancel. And now we just have to do the long division of 60 into 55.8000. Again, don't know how many we need to go out, so we will put a few out there. All right, so 60 doesn't go into 55, so that's a 0. Now 60 times what is close to 558? Well, let's see, times 8 is going to be 48, times 9 is 54. So let's put a 9 there. So that's going to be 540. Subtract that off, that's an 8. 5 minus 4 is 1. Bring down our 0. 6 times what is 18? Well, 6 times 3, that's going to give us 180. Subtract, that's 0. So now we've got our decimal form. So we had x is equal to 55.8 over 60, and that's equal to 0.93, but we want it in a percent form. So 0.93, we're going to move the decimal 2 places to the right, and then add the percent. So that's going to give us 93%. Which makes sense because 55.8 is very close to 60, so we know it's going to be probably around 90% of the value, and we actually have 93% is what it comes out to being. Okay. All right, so now we have one that has some mixed numbers for the percent, and then of what number is 78. So what we're going to have to do is we're going to have to convert this to the improper fraction, and then do like we've done before, put it over the 100, and then flip everything and do all that. So we're going to have to do some stuff, more work on this one than normal. So let's first take 108 times 3, so that's 24, that's 2, that's 3, and then we're going to add one more for this, so plus 1, so that's 325. Okay, so we have 325 for this here piece. So remember, when we drop the percent, 325, we can put that over 100. Okay, so that actually is what we have for our now. Instead of a percent, we have it as a fraction, and that's fine. We can leave it as that now. We don't have to worry about anything. We could reduce it, but we might just wait until a little bit later to get that reduction done. So now, of what number? Of, so we don't know what number, x, we don't know that, is equals 78. All right, so now we've got a simple equation. We have a fraction here, a number here. So to get rid of this fraction, we can multiply by 100 over 325, and we can multiply that by 100 over 325. And so, that cancels that cancels that, and we get x equals now, at this point, maybe we do want to reduce this. So if we do, what we can do is, well, I want my writing back. Here's what I want. All right, now we got the writing back. What we can do is say, well, we know 5 will go into 325 and 100. So let's take 325 divided by 5. So that'll go in 6, and that gives us 30. Subtract that, that's 2. Bring down our 5. 5 will go in there 5 times. That's 25. Subtract that, that's 0. So then that really is actually now 65. 5 goes in there 20. Well, guess what? There's another 5 we can divide out there. So what we're doing is we're just trying to get it reduced as much as possible before we have to take 7,800 divided by 325. So now if we take 65 divided by 5, that goes in once, that's 5, subtract, that's 1, bring down our 5. And so 5 goes in there 3, that's 15, subtract that, that's 0. So now we can divide 5 in here and get 4, divide 5 in here and get our 13. So 100 over 25 is the same thing as 4 over 13. So now let's go ahead, and now we can kind of simplify this. And what we have to do now is we have to take and multiply it out. So let's go ahead and just write it out again. 78 times 4 over 13. So now we're going to have this product we have to multiply. So now we take 78 times 4, that's 32, that's 28, 29, 30, 31. So that gives us 312 over 13 for x. Now, all we have to do is, divide this out. So hopefully that's going to be an easy, nice number, no decimals, but you never know. So 13 into 312. Well, 13 times 3 is 39, so it can't be that high. So 2, that's going to give us 26. Subtract that, that's a 5. Bring down our 2. If we multiply that by 4, that will give us what we want. That'll be 52. And so then that should give us our value we need for this an example here. And so x is equal to 24. Okay, so does that make sense? 108 and 1/3% of 24 is 78. So just a little bit, about 110% of this number is going to be 78. That doesn't seem to make sense. So maybe we've done something wrong along the way. Let's see here. 108. I think I see what I did wrong. That's 325 over 3. All right, so good example of where going back and looking at your work and saying, hey, does 110, so if we took 24 times 1.1, converting the 108 to roughly 110, that gives us 4242, so that's 264, and that's nowhere close to 78. So that clued me in on the fact that I've done something wrong here. So let's erase. How much do I want to erase? That I don't know, but we'll go back a ways anyway, because what I see I did wrong is I didn't put the right number there. And so I guess I better erase all that. And that's going to be wrong. I guess we'll just erase the whole thing on that side. And so let's go ahead and do that here. All right. So again, good example of when you do a check, it doesn't make sense. And so then you can go back and see what you've done wrong. All right, so now we've got it all erased. Now we can go back and start from scratch again. So remember that was 325 over 3, then that was over 100. And then we had to multiply that by 1 over 100 and multiply that by 1 over 100. That's the step we left off. And so now we get 325 over 300 times x equals 78. So now hopefully this is going to be making a little bit more sense and we'll get a better answer. Because what we had before was it was going to be 325% of the 24 would give us 78, and that's not the question we asked. It was 108 and 1/3%. All right, so now we're going to multiply by the reciprocal here. So the same kind of things we did before, but with slightly different numbers. 325, so those cancel, okay? So now we can think about what will go into each of these. So 300 and 325, both of them will have at least 25 will go into both of them. So 25 into 300, that'll be 1, that's 25. Subtract that, that's 50, so that's going to give us 12. That's 50, that's 0. So we have 12, and then we have 325 divided by 25, that's going to be 1 again. And so that's 75, and that's going to be a 3. And so that reduces to 12 over 13. So then we have x equals 78 basically over 1 times 12 over 13. All right, so now we have something that should hopefully give us the correct answer. So what do we need to do? We need to take 78 times 12. 78 times 12. So 2 times 8 is 16, 2 times 7 is 14, plus 1 is 15. Then we have 8 and we have a 7. Add those, we get 6 and then 13. And then that looks like 9. Now we take 13 into 936. And hopefully it's going to be a nice even number again. So 13 times, I don't know, how about 7? That's going to be 21. It's going to give us 91. Okay, so that's 7. And so 91. And then we have 26 after we bring down that. That's going to be a 2. That's 26. Subtract that. That's 0. So then here, x equals 72. All right. So 72, if we multiply that by 11, that seems like it's a much more reasonable number to get to 78. So then that would be our answer. So that was a good example of how you can look at your number and check it to see if it's close. Because if we take now 72 times 1.1, again, rounding that to something easy to do a quick check, that's 2, that's 7, that's 2, that's 7, and that's 2, and 9, and 7. And this is greater than 108.3, and that's a little bit bigger than that, but it's still on the same magnitude as before. We had 26, which was nowhere close to 78. So I agree with that number there. All right, how about the next one? So this is an application, and it says at $1.689 per gallon of gas, the cost is distributed as follows. Crude oil supplies is 95 cents out of that. Oil companies count for 0.23, federal and state tax 0.23, federal tax 0.19, and the service station counts for 0.10. All right. So what we have are two questions. What percent of the cost is paid for crude oil supplies? Okay. So what percent of, so if we say this is A, then so we're going to have X times the cost. Well, the cost is 1.689 is equals paid for crude oil supplies. Well, crude oil supplies is 0.95. And so that's our equation to set up that first one. What percent X of the cost, $1.689 per gallon, equals the cost for the crude oil supplies. Crude oil supplies is 0.95. So now we just have to divide. Okay, so 1.689 divided by 1.689. And now we just divide those out. But we're dividing by a decimal, so we have to move it 1, 2, 3 spots here. So we have to move it that many spots on the top. So 1, 2, 3. And so this is 950 over 1689. Okay. So now we have to do that division. So we're going to have 1689 into 950.000. Again, not sure how many decimal places we're going to need here. And probably this would tell us it wants a certain percent if it's less, but I don't know. Maybe I forgot to write that down. So that'll go in 0 times. Now 1689, so that's about 1500 going into that. That maybe 5 or 6 times, so 1689 times 5. So that's going to be 45. That's 44. That's 34. That's 8. And if we add another 16, that's going to be over 1,000, so that won't work. So 5 is a good start. So that's 8445. 8445. Subtract that off. So we go all the way back here. That's a 4. That's a 9. So 10 minus 5 is 5. 9 minus 4 is 5. 4 minus 4 is 0. And 9 minus 8 is 1. So that number is less than that, so we're good there. So now we bring down another 0. Now, that could be close. So if we add 1689 to this, so we'll have 9 and 5 is 14, 12, 13, that's 11, that's 8, 9, 10. All right, so that'll fit. So that's a 6. And we have 1, 0, 1, 3, 4. Subtract that off, so that goes to 4. 10 minus 4 is 6. 4 minus 3 is 1. 5 minus 1 is 4. Now we bring down a 0. That's probably going to be 1689 times 2. So that's 18. That's 16, 17. That's 12, 13. That's a 3. All right, so a 2. So that's a 3378. So now we go here, it's 3, that's a 10, that's a 15. So 10 minus 8 is 2. 15 minus 7 is going to give us 8. 10 minus 3 is 7. And so we could do another 0 if we wanted to, but maybe, yeah, well, let's do one more 0 and then we can see. Let me look at the question, what it asks for. It wants us to round, I guess, round to nearest percent, so whole number. So we've got enough now, so we can stop. All right, so we've got x equals 0.562. Now remember, that's the decimal form. To get to the percent form, we have to move the decimal 2 places to the right, and then add the percent. So it's going to be 56. And again, the 2 doesn't round up, and so it's just 56%. And so that is going to be our answer. Okay. Now B is going to be a different question. So it says, what percent of the cost is paid to the service station? Well, the service station is 0.10. So we're going to do the whole thing again, except this is going to be 0.1 instead of the 0.95. So what we have is x equals x times, and that was 1.689, and that's equal to, and we said the cost for the service station was 0.10. All right, so what do we do now? Well, we do what we just did before, divide by 1.689, divide by 1.689, and again, divide, we have to move 3 decimal places, so we have to move 1, 2, 3 decimal places here. And so it looks like we have 1689 into 100. Okay. And so since it's a whole number, we're going to have to go out 3 decimal places. And so we really don't need that 4th 0 there, because if we have that, we'll just go ahead and probably do it and we won't think about it. So we only need 3 zeros. So if we do this, 1689, that does not go into 100, so it's a 0. Now it doesn't even go into 1,000, so that's a 0. Now into 10,000, that, if we look back and we cheat, and 1689 times 5 is 8445, so that would work, but 6 was over 10,000, so 8445 was times 5, so we'll have a little bit of cheating here, so it's 8445. We've already done the math, so it's not really cheating, but it looks like it when we're not doing it on this page. Then that's 9. So now we have 10 minus 5 is 5. 9 minus 4 is 5. 9 minus 4, that's 5, not 4. And 9 minus 4 again is 5. 9 minus 8 is 1. Okay. Now we bring down our 0. Now, did we have anything that high? Ooh, no, we didn't have anything that high. So we're going to have to multiply some stuff here. So 1689, 9 times maybe, let's see. So if we take that times 9, that's 81. That's 72, that's 80. That's 54, 55, 56, 78, 59, 60, 61, 62. And that's going to be 15. That'll work. And so that's a 9. So that's 15,201. Subtract that off. So that's a 4. 10 minus 1 is going to give us a 9. 4 minus that's 4. 5 minus that's 3. And again, we only had to go to this position because now that's going to round it up. So what we're going to do is we're going to say x equals 0.059. And rounding to the nearest whole number, when we do the decimal, we'll move that 1 2 places. So that's going to be 5.9%. The 9 rounds it up, and so that gives us 6%. Okay, so 6% of the cost then goes to the service station, whereas on this one for the crude oil supplies, 56% goes to those supplies. All right, so that concludes what I'm going to do for this part of the section. Then I'll do some more examples in a little bit.